In this lesson, we're going to look at understanding powers. We're going to look at squaring a number, cubing a number, take a number to any power, and eventually square rooting and so on. So before we start, we'll ask a simple question. I'm sorry in advance for this, but we'll have to do it anyway. Why are powers like fish? How do we think? Why do you think powers are like fish? It's a bad maths joke, by the way. Okay, your answer? Because they're all indices. Indices. Boom, boom, shakalaka. Right, okay, so indices. So powers and roots can be called indices, and we'll come to that in a second. So let's have a wee look. This is how you would read powers. You should have seen them before at some point. This reads as 3 squared, really, but we can also say 3 to the power of 2. It's raised up to the power of 2 here. And in order to do that calculation, really what you're doing is multiplying the number by itself, and that gives you 9. So 2 in this sense is called the power, but it can also be called the index, which is where the word indices come from. Now later on in maths we'll just probably refer to them more as indices instead of powers, but it's okay to interchange the two. This can be read as 2 cubed or 2 to the power of 3. Usually special names of squared and cubed, but if you had a 4, you'd have to revert to this power of 4, power of 5, and so on. And that is 2 times 2 times 2. And again, we'll come back to these in more detail later, but that's 2 times 2 is 4, times 2 is 8. So again, the number here, the 3, is called the power, or can be called the index, hence powers are indices. Now powers come up in a lot of real life kind of scenarios. Human populations develop in terms of powers. They go very fast, very quickly. Viruses, avalanches is a good example of this. Now just before we come back to this slide, I'll show you what I mean by go increase very quickly. If I take this bottom number to be, say, 2, then if we say 2 squared, the answer is down here, which is 4. If I go up to cubed, go to 8, and 4 I get 16, 5, 32. The numbers are going up quite quickly, but not that quickly, but quite quickly. By the time you get to 7, you're at 128. However, if I change this number at the bottom, which is actually called the base, but if I make that a bit bigger, and let's say 5, 5 to the power 1 is 5. 5 squared is 25, 5 times 5. And it's 5 times 5, we're already at 125. 5 times 5 times 5 times 5, we're at 625, and suddenly when the numbers go up here just by 1, the numbers are getting huge down here. This is the answer to these calculations, 15,625. Again, if you make the number here really big, like say 9 for example, it's not even that big, is it? It's single digits, but anyway, let's watch. 9 squared, 81. 9 cubed, 729, 9 to the power 4, we're at 6,000 already, 59,000. So this is what's called exponential growth, or growth with powers. And again, from back to this idea, viruses work like this, they spread very, very quickly. A good idea is avalanches. Avalanches start very small, but very quickly they get really, really big. A lot of things work this way. If you play guitar and you hold a guitar up to a speaker, then it starts a small sound, but it's very loud very quickly, and you have to get away from that. And when you're graphing these functions, this is way more advanced than what you're doing, but if you're graphing exponentials, they go up like this. The graphs start off not very steep, and they get quite steep very quickly. And just recently we've been talking about the COVID cases being exponential, if you've watched the news, and that's what they're worrying about, this idea of this virus getting very big very quickly, and they're trying to slow this kind of process down. So kind of topical part of news there that's happening right now to do with powers and so on, and graphs. Okay, let's go back to something simpler, and we'll talk about squaring a number. Again, something you should have seen before, but we'll go through some examples of how to do that because they appear in the exercise. So in maths, when you're asked to square a number, it means multiply the number by itself. So the square of 8 you could say is 8 times 8, which is 64. 8 squared can be written like that, or we usually see it like this, 8 with a wee 2 above. They all mean the same thing, square of 8 squared and 8 and a wee 2. Really important to not double it. It's not doubled, it's multiplied by itself. And you can also do this, I think you'll see it later on the exercise, the area of a square can be calculated. You can say length times breadth, but you could also say L squared because the length is the same on both sides. You would just, if you were told it was 5, it'd be 5 times 5 and 25 and so on. Now, a couple of wee hints with square numbers. A square number can only end with these digits, 0, 1, 4, 6, 9, 25. And the number is called a square number because a number is a square number if and only you can arrange its dots into a square. So if you get 4 dots, you can arrange it into a square. 9 dots, you can arrange it into a square. 16 dots, you can arrange it into a square, 4 by 4. That's why they're called square numbers, and so on. You can get up 25 dots, 5 by 5, 6 by 6, and you can keep going, 7 and 7, 7 sevens are 49, so on. But the dots need to be arranged into a square, hence the word square numbers. Right, okay, so some examples. How would you write this down? So if we were asked to calculate 2 squared, you would write 2 and a wee 2 above it, write out 2 times 2, and your answer is 4. You shouldn't need a calculator for these. 4 squared equals 4 times 4, write it out like this, and that's 16. 5 squared, 5 times 5, that comes to 25. 8 squared, write it down, 8 times 8, 64. Now, a wee bit harder, we're going to look at negative numbers and fractions to finish this wee part off. So, -1 squared. Now, if you're typing that into a calculator, which we'll talk about later, you must put the brackets in, or the calculator does it wrongly. But anyway, it's -1 times -1. Now, what we've got to be careful of here, we've got a negative times a negative, and that gives you a positive answer. Same with this, -3 squared, -3 times -3, that's going to give you positive 9. Again, -30 times -30, that's going to give you a positive answer, but just do 3 times 3 and then add the 2 zeros, so that's 900. If you're asked to do it with fractions, it's very similar. You're multiplying the fraction by itself, so a half squared is a half times a half. When we do this, you do the top numbers multiplied, so 1 times 1, and the bottom numbers multiplied. So square the top number, square the bottom number, so that's 1 over 4. Same idea, a quarter times a quarter, square the top numbers, 1 times 1, square the bottom numbers, so that's 1 over 16.